In this video, we're going to investigate problems that have to do with related rates. The first problem we're going to do involves a balloon. We're pumping air into a balloon at a rate of 30 cubic centimeters per second. And we want to find out how fast does the radius increase when the radius of the balloon is 12 centimeters. The way to start a related rate problem is to find ways to relate the basic quantities. In this case, we're going to start with V equals 4/3 pi r cubed. This is the basic formula for the volume of a sphere, which is the shape of a balloon. In order to get the rates that we need, we're going to take the derivative of both sides, the time derivative specifically. So we take the time derivative, we get dv dt equals 4/3 pi 3 r squared dr dt. Do not leave the dr dt off. Very often when we take a derivative, such as I'll take a derivative of y equals x squared, we get dy equals 2x dx. Then we immediately say dy dx equals 2x. My point in mentioning this is to not forget that what we originally had was 2x dx. That is almost always forgotten about. And in a problem like this, it becomes important to remember. So we don't merely have dv over dr. We have dv dt and dr dt. These two rates are related to each other. Now, of the information we have, of course, we can simplify this equation first. 4 pi r squared dr dt. We need to solve for dr dt. That will tell us how fast the radius is increasing with time. We know that dv dt is 30 cubic centimeters per second. 30, and that the radius is currently 12 centimeters. If we evaluate this and plug those numbers in, we get 30. If I divide over the 4 pi r squared, I get 4 pi r is 12. 12 squared equals dr dt. Evaluation of this leads to dr dt, which is the rate of how fast the radius increases, being 0.01657 centimeters per second. Although we don't have that many significant digits, we should probably round it off to 1.66 times 10 to the negative second centimeters per second. That is the correct rate of increase. A different problem, another related rate problem, involves determining how fast two cars are approaching each other. In this case, we have car A that is 40 miles north of the origin and traveling south at 55. So it's 40 miles north, going at 55 south. Notice because it's going south, that is a negative. If up is positive, then down is negative. So that's negative 55 miles per hour. We have another car that is at 30 miles, and going east. It's going east at 40 miles per hour. Normally we have east as positive, west as negative, north as positive, south as negative. Reflecting the way the normal right-handed coordinate systems we typically use. In order to solve this problem, we'll first set up the Pythagorean theorem. X squared plus y squared equals r squared. If we take the time derivative of all terms, we get 2x dx dt plus 2y dy dt equals 2r dr dt. Of course, we can simplify this by getting rid of the 2's. We can also insert the values that we have in here. Currently, we have the y value we have. Let me clarify this triangle. Our triangle involves this y section right here, this x section right here, and this will be our r right there. So if I eliminate the 2's, do it with my red so we clear what we're doing, and I solve for dr dt, I get, x is going to be 30. Dx dt is 40 miles per hour, plus y is 40, going at 55 south. That south means that 55 is negative. Equals r dr. What's r? Well, let's see. If we have a triangle with 40 here, 30 here, we can use Pythagorean theorem to learn that the side must be 50. So we have 50 dr dt. If we solve for this, we get 0, 0. Over here we get a negative, let's see, 55 times 2, 0, 0 equals 50 dr dt. Subtract these, we get 1000 divided by 50 equals dr dt, negative. Or if we simplify this, we simply get negative 20 miles per hour equals dr dt. Then, so the cars are receding from each other at 20 miles per hour. The negative sign tells us that they are going away from each other. Wait. No, it means it's decreasing. It always means negative signs means it's decreasing. That means the cars must be approaching each other. Bear in mind that a positive derivative means that the quantity is increasing. If we had a positive dr dt, it would mean that the cars were getting a greater radius between themselves. They would be going away from each other. A negative derivative means that the quantity is decreasing. And since we're all assured that r is not going to be a negative number, That must mean that the distance between them is getting smaller. The cars are approaching each other at 20 miles per hour. Related rate problems are very important for, well, first of all, understanding the meaning of what calculus is talking about, and also for be able to get rates of different quantities.